let me just start the presentation. So yeah, this presentation, I've prepared two presentations. This presentation will be mainly focusing upon the synopsis of the topics that we're going to discuss today, so that you get an overall understanding of what are the different topics and the applications that uh, today's AI audiences are looking forwards, and so that you can brain map things accordingly, and then we'll get into more specific topics. So yeah, I'll have to introduce a bit about vanilla LLM first of all, regarding yeah. So before we talk about anything like agentic AI or anything, we have to understand the shift from vanilla LLM. Vanilla LLM just simply means that LLM is just used for request response structure. Like you give a question to the LLM, and the LLM will give you an answer. I hope you are really all of you are have at least once tried ChatGPT or Gemini or anything before attending this class, and you might have a fair understanding of how LLMs works. But today, this LLM, or the vanilla LLM, which we call the foundational LLMs, just pave the basement of what we can achieve today. Uh, just what we understand today. So, like, I just want to say that, yeah, today, what vanilla LLM has achieved, vanilla LLM, for example, let's say Google's models like Gemini models or Anthropic's model. I think you've heard about Anthropic, right? They are leading in some other formats. Like they have their own foundation models, but they are investing a lot on research and development, like agent workspaces, codecs, CLI command only things. So they are investing on automating a lot of things. They are defining the new standards of how LLMs should communicate with each other. They are giving new protocols and stuff. So I think Anthropic can be called as one of, now they have released the latest release of their model, which is called Opus 4.1, and they have also increased the price of these foundation models. Uh, in in other words, I would just say that Anthropic's models are the Apple of AI world, because they are inventing new stuff. They are giving a lot of importance into research and development, uh, and they are actively like uh, getting a lot of industrial experience and exposure, uh, bringing in new audiences, which we might not see with ChatGPT. Uh, now, now, what I want to try to convey in this slide is like that. When understanding agentic AI is agentic AI is something that humans have invented to by understanding the shortcomings of vanilla LLMs. So LLMs are only able to answer to a particular question. It can give you an answer. It is like a personalized teacher for you, but it cannot write you a report. It cannot write you an assignment. That's the problem of LLM. When I used to study in my college, back then this GPT-3, this paper was announced after Transformers Ordinary paper by Google. By then we used to look into the questions professors gave us and gave it to the GPT, and then find the answer. I hope I'm sure that at least some of you might have done that. But the point is that I always imagine like why uh, yeah, AI has advanced so much, but it is not able to complete an assignment for me. Like it is not able to write a docx file for me. So humans have understood okay what AI is unable to do, and now they are plugging in different technologies together to form an agentic AI. Why the name agentic AI? It simply means like it is given a particular task and it is able to solve it. That particular scope. Suppose I would start with an example like James Bond. James Bond is known as Agent 007, of course, and he's uh, with his agent eyes. What he's actually doing is that he's given a mission, and his ideal flow of action is that he has to complete that goal by goal, within a particular constraint with the tools that or the spy gadgets he's assigned to. Agent in similar ways, agentic AI in similar ways, it is an autonomous agent that is able to analyze the surroundings around it, get a fair understanding of okay, what's the contextual understanding, and then within the specific instruction from the user, it is able to pull up something really good, or like it can it can do stuff called change the environment accordingly. So let's see what are the different concepts within this agentic architectures. Okay, so simply first of all, it's perception. Of course, we have to understand have a fair understanding of what the environment actually looks like. And by the way, I'm not able to see the screen. So if you have any questions, please, like moderators can help me like uh, get understanding of the question, so I can answer the question. Okay, perception wise, yeah, it is gathering all the information available from the environment. And yeah, first step is that. Second step is the brain, which is what they're plugging in as LLM. So yesterday, I think Dr. Anis has also mentioned that not only have we passed the discriminative phase of AI, which is okay. Earlier, AI used to predict the stock market prices or the like what would be the price of a house given square 3,000 square feet. That's the discriminative part. But now, LLMs are trained in an enormous piece of corpus. The large data set are called corpus. And now, sorry, okay. And now, uh, while plugging in the LLM into the agentic framework, it is able to reason, like understand the question, and even if the user is giving a bad or like illogical thing, it is able to understand where it lack. Even if the right tool is not there, it is able to come up with a new solution and give it back to the user. And the next simple part is action. Simply after reasoning through a whole lot of change, it will finally like do something to the environment to change the environment. So environment before the perception and after the action would be different, provided that the entire sequence of flow is successful. And now we have to. I'm just going to explain what is like core difference between single turn LLM replies. What is like iterative replies? But so technically, a single LLM message is you give a question, it gives you an answer. It's simply like a question answering point. That's it. But when uh, what makes a simple turn LLM replies into an agentic control? Now the LLM is able to get a question, understand the question, talk to itself like iteratively. Okay, for example, if we are asking to find a ticket, book a ticket from maybe Chennai to Kochi, it can actually it will be able to understand, okay, the user wants to find the cheapest air ticket from Chennai to Kochi, and then it is able to divide the task into a sub series of tasks, and only after completion of each task will it be able to uh, come to the final answer. So there is an iterative planning and iterative actions that comes into play. You can actually see this in action if you have ever used uh, agentic IDEs like WindSurf and Anti-Gravity by Google. So if you have never tried like those IDEs, I think you should definitely try those ones. Uh, and I'll just show you what Google's anti-gravity is. If you tried this, okay, on the way. Yeah. So it's just an ID, but the point is that it is able to make a plan. Like only after giving a prompt, it is able to like uh, finalize it, like make a goal, divide it into subtasks, make sure that it remembers what is actually edited or like saved in the file, and then give me a very attractive and amazing goal. And this happens in very split seconds. So yeah, uh, right now in this demo, I'm not actually sponsored by Google, but still I think it's an amazing technologies, and you should also try it. Unless you want to know how to code. So if you know how to code, it's good. Uh, you can just try it. But if you're learning code, please don't try this because it's like a cheat sheet. And yeah, yeah, it has like it is like you can plug this with different types of LLM, what we call as brain. So we can plug in with different type of LLM models like Gemini 2.5, 3.1, 3.5, Flash, etc. And each have its own level of intelligence, and the response time also varies accordingly. So yeah, also funny fact that Google's Gemini models is kind of emotional. So if you're running a very long task, you can actually like you can make appreciate like make feedback comments to it. Like we can appreciate the model because of the effort that it takes, so that you get better response. Okay, coming back to the topic, I'll just close this for right now, and then come back to the topic. Yeah. So here, what we are essentially trying to see is like loop on shot. Like, oh, we have actually seen something in a direct prompt, agent prompt. Uh, here, uh, okay, and here it's simply it's just showing the setup like standard. You giving a question like, oh, tell me the weather of Tokyo and New York. What's the difference? Ideally, ChatGPT should not be able to tell the real time weather of Tokyo and New York because it's trained on a very large set of corpus and it can just hallucinate. It can just say that the Tokyo is like too hot and New York is too cold, uh, or vice versa. So grounding is something that we have to like see. Uh, and here comes the agentic one. Uh, for the same question, maybe in the agentic orchestration, you will be able to ground the truth actually. Like, for example, it will be able to run a thought process initially. Like, okay, I need to find the weather between Tokyo and New York. Uh, but I know that Tokyo is situated in Japan and New York is in USA, so probably we have to find the tropical part. And even if the hallucinated answer seems to be inaccurate, the agent will be able to self-correct the entire sequence and give you the right answer. So yeah, uh, probably that part is it. And now I'm gonna take you through a series of uh, series of continuation. So currently, yeah, what we're essentially trying to make in the coming classes is something called React agents. Agents with inner monologues. That's it. So earlier, it used to be a monolithic situation. Give a question, sometimes it looks into a certain condition and then it thinks. But now it is based upon a paper, React, which means reason and act. So even before reasoning capability, so if you just look at to Google's Gemini models, just showing yeah, most of the models right now has the ability to think right away, which is very evident when you take a new session of Gemini. And I have a pro subscription, so probably it will think for me. Yeah, it's a thinking mode. So you don't have to like analyze the thought beforehand and then process the information. For example, if I'm asking about Gemini about s- okay, right now, it's able to think. Mhm. I'm hoping it will just think. Yeah, this part, this particular part is called thinking, and it is trying to divide this question into its sub questions, trying to talk with itself, like what are the things that a user might expect, and then creating a syllabus about everything, and then gives you the answer. So that part is thinking, but this particular feature that is a recent advancement in the AI world. In earlier part, we used to mimic the entire sequence. Now the entire thinking process happening in the server side. That means Gemini is just internally checking the uh, its own thinking process and giving you an output. But you can actually see the thinking part. But earlier, we are able to, we should make the agent reason and then analyze its question and then give you the answer. So one important part of the entire sequence is a chain of thought. Chain of thought simply means that you have to like, as we saw before, we have to, given a very complex question, we have to think it out loud. Uh, the famous solution, why the solution become very famous in the AI workspace, because uh, it reduces the hallucination or the inaccurate answers by a great degree. That is entirely because the AI or like LLM, when it's thinking, it's basically token representations. Like you have a token like, okay, the cat is running on mat. Now, if five of these sentences, or maybe we are generating a paragraph with 10 sentences, if five of these sentences are very gibberish, then the rest of the five sentences we can imagine it to be gibberish as well. But if we have a chain of thought, we can actually like even before it producing the inaccurate answer, we have a higher chance of generating a large sequence of correct sequences to make sure that we streamline the format into the right approach. So that's what the chain of thought actually means. It is essentially thinking out loud. One example of how it works is that suppose you are in an interview and the interviewer asks you a question about like, solving a Fibonacci sequence or something related to string manipulation. Now, if you just write the code right away, the interviewer will not be impressed by your skill because Fibonacci sequence is somewhat very common question, and you could have just by hearted the entire sequence and give you the answer. But if you're like, whenever you're coding, if you're like declaring the entire sequence, okay, telling that, okay, I'm naming this variable this, I'm taking a for loop, and if one is writing the logic like one plus one is equal to two, and the next sequence should be I should replace two with one, and then the next sequence I'll get like one plus two, which is three, and sequence continues as well. And now the interviewer will be able to understand, okay, this is not by heart, because LLM in a very uh, rare bare metal sense, they are just by hearting the investments. But when you're given the chain of thought prompting, you are able to understand, okay, the LLM is actually intelligent, it's thinking step by step to solve a particular problem. And that's the essence of chain of thought. Yeah, and the next part is obviously decomposition, which is associated with the chain of thought. Uh, yeah, which simply means that if you are like planning for a maybe trip in Hawaii, uh, and then the LLM only has to uh, set an order for the first day, second day, and third day in separately. It doesn't have to like make an entire schema such that it will be complicated. So let's just go to this diagram real quick. What we just talk about it. So we'll start a workflow. Then we have a supervisor agent. The supervisor agent is responsible for taking. Okay, there's something called supervisor agent, which is implication of what we see in the real life. Like for example, in a company, you have a supervisor, and you are working under the supervisor. Uh, three of your friends are working under the supervisor. Three of you are uh, individually responsible for three different actions. For example, you are an accountant. I am an maybe like yeah, I'm a reception, and the other person is looking at the database or something. And if the supervisor is assigning tasks to us, like three of us, one of us should be able to respond back. Yeah, this is my domain, and I can actually do it. So supervisor actually assigns the particular task to the particular person, and in order for the supervisor to seriously understand the topic, uh, he has to have prior information about which agent is able to do which orders. So that's how prompt templates actually comes into play. And he will have a short-term memory, like okay, the user is asking this question and it is related to this context. Earlier I have answered to this context. So that's the entire part. And okay, obviously tools. Suppose if you want to stop the other agents. So suppose you want to like write a report or anything, supervisor should also be able to have some set of tools. Now we have a set of agents which is in DAG mode. DAG simply means to directed acyclic graph. So uh, in DAG, uh, you have a like clear instruction about okay which agent should actually do the task next. So, for example, if the supervisor assigning the task to me, I'm a receptionist and he's assigning task, get all the people of the reception and find his maybe date of birth from the database agent. So, once the supervisor agent actually gives me the instruction or the pattern, I should do my task and then give the baton to the next person, which is the database agent. So there is a clear instruction or the clear flow of understanding, okay, which agent should do which task. That is the evaluation of DAG. We have to check the next agent. Yeah, and then call the associated tools. And once that entire process is finished, we have to give the answer back to the user. So that part is something we have to see. Uh, Yeah, and just this is just a demonstration of what actually happens. So suppose we are having a setup of launching. Launching, if you have not seen on the thing, I know that you guys are from different backgrounds, so maybe I'll just introduce a few libraries which will be what we'll be using in the communities. So uh, there's a there's a package called launching GitHub. Um, yeah, you have this is an entire framework to like it supports a variety of tools to make your agents perform really well in the real engineering solutions. This is one of the industrial standards we use because it's extremely flexible. You have a lot of plugins. You can try to get very accurate results every time. And so this is one of the frameworks that will be familiarized in coming sections. So just wanted to show its importance in the world, right? Yep. Mm, yeah, I'm not going to like maybe yeah, it gives you like a lot of controllability, and maybe I'll just focus this on the coming sessions. But I just wanted to give you a heads up on what language it is. Yep. So yeah, we are using frameworks like LangChain. Another framework would be Letta. Another framework would be Crew AI, Agent Space. There are different frameworks which has popped up over the few AI bubble era. Yeah, and we'll be running a simple agent. Agent's name will be obviously a React agent. Uh, this is the entire module, by the way, and we can simply invoke a Python function to make a React agent. This is not really confusing, and yeah, and we are giving it a task. Okay, what's the current of Prime Minister UK and how will is multiplied by 2? Now the task requires two different things. We have to find who's the current Prime Minister of UK and find his age and then multiply it by 2. Now, if you give it to a simple agent, it might not actually work. A simple LLM because it involves multi-step approach to finally come to an answer. If you are research scholars and everything, research scholars or people who are working in the research areas, you know that your work is not confined to a single input and output sequence. So you have to go through a series of questions and then find to a solutions. So yeah, so agents can be useful in that manner because it shows you a clear trace analysis of the entire actions the test. So here in thought one, it comes into a question. Okay, I need to find the current PM. Then it searches for the current UK PM. This is actually a tool called, by the way. It is performing an action by web searching who's the current UK PM. Once it gets the answer, then okay, next observation. Okay, this is the case stammer is the current observation. Now, since this is a complicated task, we have to find his age. Now, I cannot simply like search what is his age directly into Google because I'm not giving it a contextual understanding. Right now, since it's agent and its entire memory, uh, is being like it's used within the entire sequence of actions, you'll be able to understand. Okay, I need to find the age of Kirsten. Yeah, now we are finding for the customer's age, getting its answer. Now we have to multiply it by something like 2, and its final answer is 122. You could have simply, while seeing this demo, you could have simply like taken like, yeah, why is it so hard? Because why does it involve multi-step approaches, and why do we have to like make a like do an action like 61 by 2 into a separate tool, or like connect it with some other. The problem with that is that LLMs in its foundational architecture, it's just predicting the next one. So if you, uh, not the current models, but LLM models when they were arriving, like they were scraping in all the data of the internet, they couldn't understand the mathematical aspect of it. So I am hoping that in University of Toronto, people are really looking into the mathematical aspects of everything that you do. And if you give some really complicated question to LLM, it might not like give you a particular answer. That's because you might need a particular questions to solve a particular thing, but then the LLM might not be trained to solve that particular thing. He is new to that, so yeah, and also his mathematical computation ability is also very bad. I hope that and Dr. Anis has covered that in the last session because it's one of the limitations of LLMs. Yeah, and next part is tool use, which is an absolute absolute essential part of creating an agency. So, in order to perform some action to the environment, we have to like create a capability. Uh, Before that, I would just like to show a small part of what we prepared. Mm, yeah, just so I'll just explain the code right now. User by. Okay. So you might be very familiar with Google's Gemini or ChatGPT or Anthropic. You might have seen those models, but how do you actually leverage the capability of these LLM large language models into your code, into your particular work area? And that is why we are actually taking the power of APIs, which is application programming interface. So if you go to Google's AI Studio, you can simply see this is a workspace area where you can like simply get new API keys and like do your projects right away. And this is the dashboards and the different API keys that I've generated, and it's absolutely free for you if you have if you've never tried this part. And it also gives you a like very cool interface in playground area, which consists of different parameters like hyper parameters. Now, to run a particular LLM, you have to configure certain parameters to make sure that you get the right kind of response from the model. And this involves which kind of model are you going to use, what is the system instruction that you're going to use, and what is the API key. So API key is just with this particular API key, you are getting the access of LLMs hosted by the Gemini. Uh, I think I'm going too fast, but let me just hear a quick round of review from you so that I can also listen. Hi. Hi, can you just give me a feedback about uh, if I'm going too fast? Like, it's okay.
Yes, yes. Actually, it's all fine. It's all fine. Thank you.
Yeah. And even if you have any questions, Please have to ask at the right time, because in the coming sessions, sometimes even if you don't get the right kind of foundation, you might maybe uh, maybe be completely out of context in the conversation. So please be free to tell me any kind of questions. So yeah, I'll be explaining about the hyperparameters in the coming session. And yeah, so these are the few tools and things that you can like configure from the Google AI Studio directly, and it is hosted on our website called aistudio.google.com. If you have a Google account, you can simply go into sign into Google AI Studio and then start writing stuff. You can test how things are going to work. And usually when I work and many of my friends work, whenever we have to like create an application with AI or an AI application, like there's some processing with some documents or images or photos, we actually come into this particular playground area, and then try to make a workflow of entire sequence, and then try to see if the LLM model is able to come with an answer. But if it's not able to come with an answer, then there's no point. This provides an entire prototype of what the model is able to do. So if it's not able to do in the Google AI Studio, probably it will not be able to do it in the Python code or JavaScript code that you're going to complete. So yeah, just if you are you familiar with Google AI Studio, just can you give me a thumbs up or thumbs down, or anything, like so that I can understand the verbosity of how much I should speak. Just a thumbs up or thumbs down in the chat area. Hi, yes, yeah, okay. So since people are pretty new to this Google AI Studio, I think Tina, first time is okay. Can some more people give me an answer so that I get an overall idea about how about it first time? Okay, cool. Okay, okay. So for the people that that don't know what a Google AI Studio is, like this is what I've explained so far, and you can just run your code here. Maybe for example, if you want to find who's the Prime Minister of India in 1995, you can actually not only does the not only does the LM generates an output, but you can also ground the entire sequence with a Google search API. So first, the Google search will go through the different questions that you convert and use that context to give you the right answer. So if I ask like who is the prime minister, and run with control and enter, it will try to uh, sorry. Uh, okay, this entire sequence is grounded by Google search, uh, and it gives you correct citations of the entire sequence. But if you turn off this feature and give you ask the question like who is the president of uh, in that way, now we are not grounding the entire sequence. It's actually thinking. So if we expand the entire thing, we can see what it's been thinking so far, and this will help us to debug. Okay, what's the problem? The LLM output is the giving from. So now the difference is that it's giving the right answer. 1977. Okay, we have three. Didn't know that. But the difference between the first and second query is that now grounding is there. So for each of the answer it gives you citations on where it has actually come. So if you go to the particular citations, say yeah, it's giving 2 and 3. So if you go to this particular site, I don't know, it's okay. Yeah, from this particular site, it's giving the right answer. So it's saying that I'm not just hallucinating anything, but I'm having a solid piece of evidence to ground my truth. That's the AI Studio, and I'll just go quickly by the what the sidebar is actually giving me. So it gives you temperature something. Yep. Before temperature, let's create an API key for you to use. So there's a section called get API key, and you can just create an API key right away. You can just copy the code and then use it in your Python project. That's how the Python code actually communicates with the Google LLM studios. So in my code, mm, so you can just create an API key, give it some name, and then enter. So you can get the API key. And it actually looks like if you are like anyway feeling like this is going too fast or something, I'm just making you familiarized with the different platforms and things, and then finally we can come back and solve the entire thing. Okay. Um, okay. Here is a simple Python code. Don't think it's a very simple code. Here, what we are essentially using is we are going to the Zenite capability. We are using the Google's Python package, and we are giving some configurations, and then trying to give it a particular answer. Let's see how the answer turns out. So, in order for this Python code to work, we have to see like what are the different settings that are used. So, I've used model. So, whenever you are making a call to Google, you have to configure which model you're using. So in my case, I'm using Gemini 2.5 Flash, which is kind of latest model, but I'm using the Flash variation. Flash variation and the Pro variation, there is a difference between Flash and Pro, which typically differs between the number of parameters both of symbols are. So, for example, um, Google's Gemini 3 model, estimated size. It's a proprietary model, so you probably wouldn't get. So Gemini 3, at least in 2026, is removed to 1.2 trillion parameters. So whenever the number of parameters increases, you have an increased computation, also increased intelligence and increased. It is able to solve complicated scenarios very fast. There are few techniques to reduce the number of parameters and increase the number of intelligence, increase the amount of intelligence. That is like using like different mix of expert model, which is like you have an expert on each particular domains of your work. For example, for medicine and arts, you have two different models, and depending upon the type of question, you pass the entire sequence to the right model, and then you get the answer. So yeah, I guess like asking questions. Sorry. So whenever the number of parameters increases, it is supposedly more intelligent. So I am using Gemini 2.5 Flash model, which is will be lesser compared to the Gemini model. This is 5 billion parameter, maybe the half of the size of the newer models. So yeah, depending upon this size of the models, the prices, the latency, and everything also. Uh, consequence. Yeah, depending upon the parameter size, also the model's intelligence hugely varies. Now let's back to the code real quick, and I'm asking a question like why is the sky blue, and I'm setting few parameters like we have seen in the Google AI Studio. So if you can. Uh, Sorry for the delay. So here also, I'm giving a few parameters while generating the response. This is very identical to the Google AI Studio parameter in the sidebar that we've seen earlier. So yeah, I've set the temperature to 0. I'll be explaining what this configuration actually, why this configuration actually matters. Yeah, so we have some of the components like temperature, top P, top K, C values, etc. Um, and simply by invoking the code, I should be able to get, sorry, this is a Python code. I'm using something called UV. So yeah, you can run the code. Specific. And I'm running the code. Let's see if the answer pops up. Yeah. So the question is like, why is the sky blue? And the explanation is that the sky appears blue primarily due to the phenomenon called Rayleigh scattering. Sunlight which appears white. So we're getting the answer. But the problem is that, will I get the same question? Will I? Is it giving me the right answer, or should I do some kind of grounding? So that's when Google grounding or something like that actually exists. You give a reference document to it, um, and then based on that document, you can infer the right response. That's something that we used to call RAG, which is retrieval augmented generation. That you have a set of right answers or the policies, and then you refer that policies to get the right answer. And the next question: Does the uh, does it answer the same all the time? Let's check it in. Yeah, it appears to like give you the same answer right now. But what if we change some of the parameters? Yeah. So the three times it's giving the exactly same answer. But what if we change the seed value right now? 7. And then after saving, I'm running. Um, Wait, let me just tweak this a little bit. Okay, now the answer is pretty different, right? So based on these parameters, the number of the kind of response it can give is very different. And suppose if I run it again, yeah, mm, since the seed value, so the same kind of response is given by the seed value. Uh, yeah, so I'll be explaining about this separation conflicts very soon. So the entire idea is like the temperature parameter, which we can see from here. We have a couple of parameters that we can tune, like the thinking configuration, like how long it should think, what are the speech configuration, like how many tokens should I cache. Cache means like even before processing, it is already computed. And what are the different tools that I can use with the model. So everything is like configurable within this entire sequence. And the temperature, this part specifically focus on how creative the answer should be. Simply means that uh, if the temperature value is too much, like the maximum we can go is like 2, the kind of variation or the creativity the model tries to achieve is very, very, very diverse from what the answer should look like. So if you have a temperature 2 or the maximum, you kind of anticipate like the answer could be a little bit stupid or like inaccurate because it tries to hallucinate a little bit. So whenever building a very scalable products within the uh, like financial sectors, we'll try to take the temperature to maximum 0 or 0.1, depending upon the use case. And then we have something called top P and top K, uh, which specifically focuses on okay, the number of candidate tokens that we can take based on probability. So if you're setting the threshold to 0.95, only those tokens which have a threshold of 0.95, above 0.95, would be taken into case. This also means that we are actually limiting or the constraining the model to give you the very set of tokens that we require. Now we have something called top key, which also looks into something like that, like use a probability distribution and then tries to get from the sample data set. Uh, Now we have a seed value. The seed value is important in a scenario where you kind of require the exact kind of reproducibility in every run that you do. So if you don't provide seed value, it is probably going to give you very different variations of responses every time. So that's the difference between seed value and temperature. This is a very crucial part in this. Um, and here we have something called maximum output, which simply understands. Now you can see the structure of the sequence changed very bit. Like earlier it was explanation, now it is reason. So depending upon changing the parameter, the entire response structure also changes, which is not ideal in a production grade system. Also, we have something called maximum output tokens. So in LLM, um, you go to their site. So if I see, you go to the documentation. So this is how we usually use Google, I mean Gemini API keys. And for every input tokens are costly, output tokens are whatever set of sequences that we are giving here is the input token. So probably this would be around 5 tokens, and this would be around some other number of tokens. And how do you? I can even see like the entire response structure run by the Google. I'll show you that. It actually gives you the count of tokens as input and output. Let me just okay. So it's giving you the output answer and also giving you the number of tokens it actually processes. So input token is 7 and output token is something like 416 or 496. So based on this number of tokens LLM generates, you are actually paying the Google or the Gemini. Okay. So if you look at the uh, like pricing, it's like for 200,000 tokens, it's $1, which is like heavy because they're using the production rate system. But for us, it's like Gemini 2.5 Flash. It's like around nothing, like $0.15 per like 1 million tokens, which is actually nice. Um, so basically, what I was trying to say is that with that particular API, you're able to see the entire uh, name of the model, the response structure, the request number, uh, everything. If it contains something like different modality, like images or text or speech or anything, you could probably see everything within this request section. Uh, yeah. What if I want a shorter sentence? So you can just tweak this maximum output token since we have like configured the tokens within 500 tokens. We are getting the output as 416. Total tokens is 416. But if we are increasing it to 5,000, we will be getting a lot larger response based on our prompt and everything. Suppose like, what if, like you are generating something and suddenly like name like some words which are not parliamentary used are coming into this large language models. You should stop the response immediately. Right? So for that aspect, we can actually set a set of sequences that we can stop whenever they are generating. So you'll not be, you don't have to like generate 5,000, 6,000 tokens and then filter out those tokens. So you will already like, yeah, you don't want to pay for the entire gibberish it's going to process. So for example, if the color of sky given by the LLM is 50% blue and 50% times green, we know that green is not the right answer. And generating the entire sequence of tokens, to finally understand it's green, you don't have to waste that many tokens or waste the money. So suppose like if I have blue and I'm like, now, one second. So if we while generating, if we ever encounter the word blue, it should stop. So it should not produce these larger outputs. It should stop immediately. And let's see if it stops immediately. Yeah, it stops immediately because the question why is the sky blue, and the answer is stop because like it is going to, why is the sky the next token would probably be blue, because it has already encountered the blue, which is a stop sequence. It's stopping the entire sequence, thereby saving a ton of tokens. This is the simplest LLM response, and how the next topics will be about how we are going to incorporate these models into the coming slides or application. Let me just come back to the sequences real quick. Um, yeah, while how is the agentic workflow actually works? So since now we have a fair understanding of how an LLM can simply be used in the Python framework, we can actually plug in these LLMs into an agentic workflows. Maybe I'll share the uh, collab right uh, in a few minutes so that you can also try with me. Uh, but let me just quickly go through the entire sequence. Now, okay. So provided here are three of the major workflows or different architectures or the different types of design that we usually bring into agentic. Based on these designs, we are actually building our agentic architectures. So provide are three different things, which is one reflection, second is iterative refinement, and third is multi-agent system. So we'll start with the first one. What is reflection? Reflection is based on the idea that okay, the agent itself has the capability to uh, reflect upon its own mistakes. So whenever it encounters a mistake or it tries to think, okay, where did I go wrong, based on the reason and act principle. So uh, agents based on this reflection method is going to be a very simple agent or like a very monolithic agent. But if we want to like have an iterative effect, for example, we are plugging in two, three different types of agents in a sequential manner, which would mean like, for example, uh, yeah, we are giving a question and one of the agents is responsible for giving an ideation and giving to the next agent for prototyping and next to the reply. But for iterative refinement, you need the if the answer of the output of the first agent is not working, you have to give the feedback entirely to the first agent, and then you have to iteratively improve the product. The downside of this iterative process is that it's cost. It's very costly. Although you can see how the application has evolved from the inception phase to the final state, it's still costly because it involves a lot of tokens and lot of effort, uh, while lot of time, lot of effort, lot of money when coming to the final solutions. Now we have something called multi-agentic system, or it's you can simply be called a critic agent. Now the paradigm of the multi-agentic system is like you can simply think of it like captain in a ship. The captain assigns there will be different agents in the ship, each responsible for maybe dropping an anchor, like straightening the sails or like sailing. So each of these agents will have its own designated task, and the captain will be able to correctly design okay which agent should do which thing. So that's the part of multi-agent system. This is very useful in modern applications and stuff. Mm. Now I wanna okay. This was the synopsis of the entire sequence. I will just stop here and just go back to another slide which I prepared. Okay. Now like I'm going to go into a little bit more details about the entire thing. This is the round two of what we have taken, so that you have a fair understanding of what we have talked about. And now we are going to repeat the same thing, but with a different, little more context awareness, so that you have a skim. It's like a skimming the uh, textbook right before the exam a couple of times. So right now we are going to deconstruct the agentic AI. What makes an agentic AI? So agent is nothing but a brain, which is LLM, which acts like a core reasoning agent, and then it has some external. abilities and capabilities that we have defined to the agent. We've also defined how to use the agents and what scenario in the prompt part. Prompt part is where the instruction to the LM is being defined. It will also have a memory space where would have recorded many types of interaction that the user and the LLM would have had it in the past. So, if, for example, if I'm using ChatGPT and it has like a lot of sessions in the left side. Uh, if it knows that I'm working on Python or like Next.js, there's no point in giving some alternate code in Lua or like TypeScript or CSS. And any those snippet is invalid for me. Like if it gives, if I'm trying to implement a Fibonacci sequence and ask it to give a code for me, it will just look at the past interaction and see that yeah, I am using Python in my daily life. So I LLM will give me the right code in the use its memory to give me the right kind of response that you prefer. Uh, yeah, and what does LLM do? I'm not going to go in depth to these parts because we have like workflows and stuff to complete. Um, so yeah, the main part is like you have the LLM is able to understand the different features or whatever you're saying in the common English language, not the programmatic sense. In normal English or Malayalam language, if you're saying anything, it is able to understand the sequence and generate the sequence in the similar language. Um, so the entire sequence is sponsored by Attention Solid Paper. And why is LLM a game changer in the AI segment? Because Attention Solid Paper by Google, Vision AI, and others has been. So they are able to solve a very peculiar uh, problem that the AI world has faced for many years. And one of the things was like the LLM would forget any large set of sequences that he had test processed before. Training a large set of tokens or large set of data set was extremely cumbersome. So attention solving paper. Let's see how this attention solving paper has the ability to solve the all the bottlenecks that we have seen so far. And here, let's say an example. The animal didn't cross the street because it was too tired. Now, there are like two nouns in pronouns. One of this animal and other is street. And the next sentence, next word is like it. But it doesn't, it word specifically doesn't have any meaning associated with it. Whenever a human understands it, it's like it is representing either animal or a street because it can represent in nouns and verbs, right? But when human understands it, it kind of understand like okay, another word associated with it is tired. So a street can be tired. So animal is a tired. So here attention mechanism comes into play and give you a high score to animal and low score to street. This is what the entire attention resolution paper talks about. Earlier, we used to have recursive neural networks and long short memories that was able to generate set of sequences. But the problem is that whenever, uh, whenever the output, whenever you train the data, it naturally the gradients are become like the entire sequence works on something called backpropagation, right? I think you're familiar with backpropagation. Uh, I'm assuming that you're familiar with backpropagation. So even if you are not, I'm just like telling it. When you're training a data set into a LLM model or a model, any AI model, it has to learn the weights. It has to find the approximate weights to come into a particular solution, like give you the right answer. And this is a very reiterative and a uh, cyclic approach, and uh, that needs to for the back propagation to work, we need something called gradients or how the weights are changing when a new input is coming. RNN and LSTMs suffered a little bit too much when the number of sequences and number of data sets were increasing, and it could only process the data once at a time, not like other transformers, which could give attention to all the tokens simultaneously at the same time. So some of the features, novel features that included in the transformers or any people is something called positional encoding. So it was able to correctly encode, okay, animal is coming with the first part, so their positions and position of animal is also important, as street is important in the middle part and tired is important in the last part. So it was able to give you positional information about how the encoding should go. And then something called multi-head attention. So, uh, then multi-head attention was able to look, give attention, many types of attention to the uh, one particular word. For example, attention can simply means that uh, dog seems to be like an animal, it's living and it has a lot of properties. So any value associated with these different type of attention, it is able to correctly capture in the word dog or animal. Uh, and then yeah, it similarly works on feed forward networks, which is also which is also a part of earlier models, but now we have something called attention heads intertwined with this feed forward. Now, this is a simple factor of attention. What I've already told you, attention is the single most important part. But what is attention? Like attention is simply a mathematical formula that it gives you like a matrix kind of way to uh, correctly emphasize those tokens that requires to be noticed. And like how did it enable us to come so far? Simply by giving a parallelization. Like you can earlier we could only train one that is a, after it comes like to give input like to distinguish between a cat and dog, it has to completely back propagate back to the area in order to run the next set of patches. But here it's more like you are training the entire sequence in a parallelized manner. You're giving input and is able to understand this weights mechanism and a layer by layer or layer by layer. And of course, the long range dependency issues was also solved because we are giving attention to an entire sequence of the tokens to predict the next tokens. I think I've already gone through what Google Gemini LLM is. Like there are different models available. You can see here also. So you can take any of these models apart from Pro, which might require yeah, paid tier to access. Other than that, you can take any kind of model and then plug into your use case. So I'll quickly go into yeah, these are all kind of talking the same thing. Okay, LLM providers also OpenAI, Anthropic, Azure, IBM, Watson. These are the different LLM providers. You can use that. Now I'll just share the code right quickly to uh, yeah to make you also do something. Let me just take sorry. I think I can share the screen. Share the workshop. Mm, okay, and I will be sharing you the collab. You can make a copy of it and then try it on your own, so that you'll have a think about what we are doing and what I've explained so far. Mm. Are you able to open? So can someone open it and see if you're able to access it? Otherwise, it might show some kind of authorization issues.
Sir, it is accessible.
Okay. Okay, nice. So you can make a copy of that notebook, and let's run it together. And meanwhile, if you have some doubts, we can clear things up. Shiva? I think I've shared a very see. So, okay, my task was simply I was going to create an agent that can read data from a particular file uh, and then evaluate the data and give you a maybe analysis of the CGPA or the brands or any other details. And even if I wanted to add some other people into this CSV file or the report, I can actually add it. So I'm starting from actually the middle part of this. Uh, so I hope you were able to connect it here. I'll just walk through the code. Mm, okay. Now the runtime is connected. So the idea is that we have to first create sample data to make sure that we can operate it with LLMs. So we are using something called Pandas library here, which is a very foundational package, data analytics or like data storage, those parts, creating stuff into tables and analyzing those tables row by row. So we are creating here with some uh, columns like name, CGPA, brands, and year. We are giving the names and some CGPAs, brands, and year, few sample data set. We created a data frame. This data frame will be once the data frame is created, we will be like storing the data into a CSV file. CSV is just a common submitted file similar to an Excel sheet, right? So this part is done. So let's see if this data is working. Yeah. Now we can see the students.csv file is being loaded, and if we take first five element of it, you can see it's written in this format. And the next part is like we have to okay, suppose I'm a teacher and I have to add new students' data into this Excel sheet. Okay. I can either go directly to this Excel sheet and then write the information, or I can ask an agent to give a give an entire set of other document and ask it to write from that particular part. I can either like create a found, like find different analytics of the solutions on my own, or can make a agent do the entire task. So for that purpose, like I have created two tools, and these functions will be the tools. Uh, yeah, this so these functions will be these are the functions or capabilities that we are going to give it to the agent. And so this is called a decorator part. We are using LangChain's decorator tool to like make sure that we agents can understand. Okay, this is the tool that I can use. We are creating another CGPA function to like find the average of different students based on year, branch, and everything. So and also we have to maybe create another weather application. Okay. So now we have three different set of capabilities that we are going to give it to agent: get weather, add student, and get average CGPA. So now we are going to uh, like run the code. Uh, so yeah, we are going to create an agent really quick, and this agent is simply a React agent. with set of instructions and what are the different kind of configurations that you can give. I'll not be going in depth to each of these sectors because each of these sectors are very very significant on its own. But for the simple agent to work, you might only need to give uh, the mandatory things, which is like agent's name and brain. Have you created a brain before it in this step? Yeah, yeah. This is the API key that I've given. I think this is my API key, but you can also create your API key from Google Studio, and then you can generate your own API key once you have signed in with Google. So if you have uh, in this particular part, you can just copy the entire sequence and give it here. It should probably work. Okay, and uh, here I'm just trying to create compile an agent. Very good with brain as LLM, and I'm giving a prompt really good. Like you are an intelligent agent that can manage student data. You can add new students. This is a capability that I'm giving and calculate the average CGPA for a given year or branch. Use the provided tools to perform the actions. So I'm giving the tools access to this particular agent, and uh, I'm also turning the debug flag on so that I can understand what's really happening. So whenever I'm giving a question like add a new student named Sarah to CGP 3.7. So someone come. Okay. So here just okay, this is a compiled agent. We call this a compiled agent because we are invoking a function called create react agent, which we have seen in the earlier part. Uh, Once that object is created, this is an agent uh, ready to run. So we can just give give its answer. Like we can invoke the agent with corresponding human message, which is like add a new student named Sarah with CGP 3.7, CSEA, and year 2025. So once this application completes, let me just remove this top output screen first, and then I'll run it. Okay, wait 1 second. So it's installing LangGraph, which is a part of LangChain, and uh, of which part is the React agent. And once it's finished, it's configured. I'm trying to invoke the agent directly. Here, you might can actually see the output. Okay. Here, it's giving a series of input and outputs like updates and values you can use to check. So I'm giving a question like add a new student named Sarah with CGP and something something. And yeah, so that's a request. And now the agent is able to call a particular function to add an agent, add a student. Now we have an arguments like for a student to be added, you need a particular set of what you need a particular set of data. Like you need name, you need CGPA, you need trans, and you need year. Given this information, you are able to like uh, get the load the data frame, insert a new set of row into this value, and output that student's name is added. Let's see if it's working. Mm, oh, since some other people are using it, it's exhausted. But since I have other copies, I'll just show it. Really. Okay. So, okay, that's the other part of. I just want to explain why this error really popped out. That's because I think all of you are using my API key, and since I am not paying anything to Google, uh, like they have a strict limit to how much requests that I can send within a span of like 1 day or two. Since all of you are trying on your own with the same API key that I provided, you will be facing the same issues as well. So to solve that particular issue, you can add Gemini API right here. There is a secret world type secrets like session here, and in the API section, you can like paste your API key provided from Google AI Studio. So I can just copy it, paste it here. Maybe you can see it, and yeah, that would probably be it. That you can run. But since all of my API key is registered in the same project and location, sometimes it wouldn't work. So I will just try. Is if you are like running this, please make sure that you have generated a API key to run this sentence. Maybe I'll get a timeout error. Let's see. Yeah, I'm getting a timeout error because of resource exhausted. But if you try with your own API key, you wouldn't get this. Mm, okay, guys, please tell me like if you are able to like do it and get the right response. Please be me. Since we already have output, maybe I can explain that in the meantime. Now, like once the output is registered, Spark, okay, uh, okay, I'll be getting the same kind of like token issue, like yeah, runtime issue because of API exhaustion. Uh, okay, I'll be explaining the output of the entire sequence. So okay, now since we have a compiled agent, I'm trying to ask a question like what is the weather in Kochi? So it will not have an access based on the things it has learned. So it has to like invoke some tool or capability to find the answer to this question. So before that, we have already configured like so this one. Yeah, this is a tool section that we have run in the first section. So here we are defining three tools for it, like getting the weather of a particular city, adding students information, and getting the average of certain students. So if I'm giving the name of the city as Kochi, or if I ask it to find the information about Kochi, then it should return. This tool is just a mock data, but ideally what it should do is like contact the weather API, uh, like any API from weather providers like weathercast API or something, and then give you a set of strings. And the LLM will then analyze this string and give you the right response. So if you can see here, it is invoking a function call like to get weather. and the name of the city is Kochi, right? So it is giving city as Kochi, and it is waiting for the response. Now, yeah, and the next value is like mm, it is getting the weather of the Kochi. Okay, once the tool is invoked in this particular section, it is the response from the tool is that okay, the weather in Kochi is sunny with temperature of 30 degrees Celsius. So the agent is able to get information from the tools, and now its responsibility is to report it back to the user that okay, the weather in Kochi is 30 degrees Celsius. So this is the response that we are getting. Mm, yeah, you can try this on your own and maybe like tinker it with your own responses and see how it works. This is the output of this is the expected output of what the code should look like. Mm, so here I'm asking it to add a new student with Sarah's 3 point CGPA 3.7, and it is now invoking a function called okay. I want to call the particular. I have a okay. It looks into its tool inventory. Okay, it has get weather, add student, find the average CGPA. So it will choose the add student with corresponding arguments, and uh, it will like once the tool is invoked, it will actually add the name of Sarah to the CSV file and then report it back to the user with CGP 3.7. Then user added Sarah is added. Okay, and what about like what if we want to find the CGP of CGP average of students in 2025? So once we are giving the question what is the average CGP of students in CEC branch 2025, it updates. Okay, it invokes and tries to see okay which tool I want to use. Okay, it selects its tool like get average CGPA and argument is CSV. So once this tool is selected, it executes the code, like executes a particular action that we have intended to do it, and based on the output, it finds the answer like 3.833 is the final output. So that that will be something that the agent will respond as back to. So that is an that is the overall idea about what is agent. So like we discussed, sorry, there are other few things that I also want to add. Okay. Like we discussed, agent is nothing but set of LLM, set of tools, set of memory. Memory part we will be focusing tomorrow because it has its own like technical depth, right? There are lot of type of memories, lot of ways by which we can manage these memories. Uh, why should we manage these memories will be covered in the next section. And yeah, uh, I also wanted to take a little bit class about prompting or prompt engineering part, and this will uh, like really guide uh, how the agent is going to perform given a particular set of questions or series of questions. Yeah. Now I'm going to take about prompt. So since we are all of you are very active in social media, Instagram, Twitter, and stuff, prompt has become a very significant part of our like, daily enjoyment. You can just give a model to like, generate a particular very specific kind of questions, very specific kind of style for your like input data. So there is a site called Viral Prompts. If you have never tried it, you can just go to Viral Prompts and see different set of prompts and their demos. Now, prompting itself is a very we have to clearly understand what this LLM lacks and how should we able to convey the meaning rightly, beautifully, without any ambiguity to this end. So yeah, that's the part of prompting. I just wanted to explain the types of prompting. Yeah. So the art and science of prompting. The slide mainly focuses upon what how does like tweaking a little bit of input data in our prompting actually output the LLM output the data very differently for each input. So there are a couple of techniques that we can adhere to make sure these are the non-technical or the industrial techniques that we adhere to make sure that LLMs can respond effectively in a way that you had designed it to. Otherwise, it would be like giving it a very cheapest thing. Now, okay, you can either give it like zero shot prompting. Um, there are techniques like few shot learning and zero shot learning. You might have already heard it in the previous session, which means that when you are asking, when okay, zero shot prompting simply means that you are giving a question to the user, so to the LLM, hoping that it uh, hoping that it can find the right answer. Like for example, Ramu seems to be sad. What kind of a what kind of motion does this sentence convey, positive or negative? Now, this exact data set may not be contained in the corpus which LLM is trained upon, but since it is able to identify the patterns, it will be rightly able to guess your answer. But that may not always work. That's why we need few shot learning. You are giving a series of uh, like examples, question and answers, so that from this question and answer, the LLM can correctly identify the desired input and output. Sometimes few shot learning also fails in particular scenarios. And that's when we need like a chain of thought. Like the program's name, chain of thought, simply talks it loud. Like okay, the user uh, is able to like divide complex questions into very tiny or simpler steps, and then things into each part and tries to make uh, try to find out a way to come to the right response. Now, we will explain more about all these data sessions. And there is something called role play, which essentially means that you are giving a role to the agent, so that you're giving an identity to the agent, like maybe a supervisor or like maybe a teacher, maybe a like a report maker, and so that agent knows that okay, its main part is to like do this particular task associated with this particular role. And for example, if you are uh, given a role of uh, teacher to a particular agent, and then ask about show me how to do a like how to fly an airplane, he might not that agent might not really answer your question, because if you prompted in the right way, like we prompted that agent is a part of elementary school teacher, it will explain in that matter, not in a very technical depth. Also. So if you are like scholar students, you can actually give uh, like responses in you can prompt in such a way that okay, I'm a scholar student, you are a scholar, research scholar, and your task is this, and you can apply different methodologies like this and this to come into a particular solution. This will make the agent follow a particular trend or like an industrial standard to come into a particular solution. Now, uh, an example of how this can be seen here, where you give a role like act as a senior cybersecurity auditor with 20 years experience, review the following firewall, and identify three critical vulnerabilities. This will enable the agent to recollect all the things related with senior cybersecurity auditor, and it will then try to analyze the code or the firewall policy with that mindset and experience in its head. And yeah, next one is chain of thought. So we're giving a mathematical question which seems simple to us, but for a LLM that generates token after token, we call it uh, auto recursive model. It is only it is not able to understand the mathematics as humans understand it. is only able to identify certain patterns like 1200 minus 500 is 1500 based on some data it has seen before in its training patterns. So you cannot like completely trust an agent or an LLM without a chain of code. So you are giving a question like, I need to calculate the return of interest per new marketing, and I spend 5,000, expect 200 leads, 5% conversion rate, and average. So you have to think in this sequential manner. Calculate the total number of customers, then what's the next step? Then you calculate the total revenue, and then what's the next? Calculate calculate the next net profit. Finally, provide the return of interest percentage. Otherwise, it will not be able to completely come up with the right response as you expected. Moreover than that, it will be completely hallucinating for each question. Now, there is something called constraint-based prompting. That is, you are giving a set of constraints, uh, maybe like, and make sure that the LLM doesn't cross that boundaries. So, how a refrigerator works, and the constraints are like use no more than 100%. Should be concise. Do not use the word coolant or electricity. Much like our like stop word sequence, right? It shouldn't use coal and electricity. So yeah, and write it in the fifth grade reading level and respond with a one sentence safety. So this is you're actually engineering how the response should look like with this constraint from point. That's basically it. And let's look at some of the other workflows. Sorry for that matter. Yeah, I just also want to tell you. Um, okay, since we have had a like understanding of how this works in the code level, I there's something called AI uh, workflow setups. So, so there are basically two types of workflow AI orchestrations, which is workflow and agentic AI. You might not need agentic AI all application that is like you are looking for RTX 3060 Ti for a simple like random forest model. You only require agentic architecture only when there's a need for autonomous. Like the agent can decide for its own, it can analyze the input on its own, even when there are variations within the input. Like for example, even when there are different types of different formats of document that you want to process, and based on each type of document that you have to like invoke a different types of agents, then only you need agents. But for very streamlined workflows, for example, if you want to get the data from a document and then store it into a particular area, you might not need agent in that particular aspect. You might not need AI AI agents to like signal processing or understanding signals and then converting into natural language understanding. You only need agents when there is power of autonomous which is needed. Uh, so I just want to explain what are the other things uh, why why workflows where agents are like buzzword in this sector. So there is something called uh, just show you a new technology. So there is a new thing called it's not a new thing, but for the people who have not heard about it, this is an AI workflow automation setup. It's a platform where you can like orchestrate different type of workflows. This can seem complicated, but it's pretty simple if you look into some of them. Some of the applications that we can use. Uh, it's simply like drag and drop. You don't need to code anything. For example, if you're a teacher and you need to like you need to maybe uh, collect a form from students and mail to them based on their preference. Like for example, you're collecting a Google form from students, and if there are like two options, they are interested in AI, they are interested in blockchain. And based on this preference, you want to mail them with the appropriate programs. You might not need agent in that space. You can simply like connect these dots together and perform the action correctly. Like, here, what is essentially taking like when a chat message comes, the AI agent like uses the capabilities from LLM models, and it also has a simple storage to store the conversation memory we have, and then stores a particular type of JSON into an Excel sheet. For this very streamlined, very unambiguous, very clear, distinct workflow, you might not need an agent. Although it's named agent, it's simply a workflow, right? To orchestrate this kind of workflow, you have a platform called Anytime, and this is very popular in the sector. Uh, so you don't have to like learn coding from scratch. You can just keep it. You can just drag, drop, and configure things. I'll just show you a little, and also it's open source, so you can deploy it in your own servers and code accordingly. Even if you don't have servers, there are like cloud supports associated with it. So it's pretty neat. Like you can just connect these nodes together and perform whatever you want to do. It's pretty neat. Uh, so I've also had a container. I can run it in my system actually. So I can actually run it in the system. So yeah, I'm actually running it in my system in a local host setup. So for the people who are not familiar with local host also, it's basically I'm running it in my own computer and I accessing it via web browser. So probably I'm gonna be having a host. Local host. Okay, so I'm running this container. So you can actually create your own workflows here uh, with this setup, and there are like tons of templates that you can go. Here, I'm just making a chatbot real quick, so you can. I'll share this template for you too in a JSON format for you to understand. So basically, the workflow keeps like let's see what he's doing. Okay. Essentially, the workflow. Uh, the purpose of making this workflow is that you should be able to communicate with your Google Sheets, which is an Excel for Google, right? So you should be able to chat, and you should have an agent or something. And this agent's major capability is that you need a brain to understand what you're talking. So you need an OpenAI or chat model. You can simply switch it for Gemini models. So right in this corner, you can have like different like flows and stuff. And in the AI part, you can get different providers. And here, these are the actions. Google's and all reviews. Google's and text actions. So once you've configured this part, once please. Yeah. Uh, simply by like sorry. Yeah, you can like keep a model like this, and it's just drag and drop, and you can just press Control and Enter to configure this model separately. You don't have to code and configure everything. You can give your prompts here, user privileges here. Uh, you can set. You have just the fact that you have to like have a credential for that for Google Generative, and you can like copy your API key here. And once this thing is saved, you can trigger the action. Like you can just open the chat right away, and in the chat section you can ask some things regarding anything which is associated with your Google Sheets. So in order to run this Google Sheet, you have to configure the credentials, give access to your Google account and Google Sheets, and you can just like run the Google client ID, which I'll be showing in the next class. Because there was some problem running the workflow when I was trying it. Yep. So anyway, we'll be showing in the next class, coming classes. So you don't need an agent or agentic orchestration to run this entire schema. Just have to be like a simple workflow to finish it. Uh, and this entire section can be configurable, and I can share you a link of the configuration file that I've used. Given this simple link that you can copy paste in the export file manager. Like you can create a workflow, import a system, just add things to it. You can add things like this. And once this is configured, you can just connect and execute a workflow. And if you want to like import a workflow from somewhere, you have like 7,000 templates from N810. In the N810 site itself, you have like many different templates for you. So you can just download that templates and use it for your own access. You can see workflow templates here. Yeah, you have like around 7,000 workflow automation templates, and you can search for use cases like Google Sheets. Things related to Google Sheets, you can just uh, find maybe like nutrition tracker. You have a workflow for that. You can just track the nutrition and give alerts to the Telegram agent. Uh, you can see the different workflow that has been configured here, and also you can copy this template, right? And then just copy this template, create a new file like maybe n8n config.json file, and then save it somewhere. And next time you open the application, you can just import that entire schema right in this application. Maybe I'm going a little bit faster, but it's better. Yeah, this is a new configuration that I've created for workflow automation. We are just simply importing this sequence, so we can have an in-depth understanding of what is happening in this workflow sector. Once you can simply run this in cloud, so that if you send a message to the Telegram into a particular chat, it will trigger all these workflows for you, stores the information into a Google Sheet for you to finally understand the data, and then maybe use that data for uh, preparing a report or like any type of things. So that is probably today's class that I'm looking forward.